Okay, guys. Let us continue our class. So actually, we just use this theorem of translation force. We can use this similar step to tackle all the forces one by one, right? That means when we move F1 from here to here, we add a M1. That's how we get the real magnitude and real direction of F1. And when we try to move F second from this point to this point, then we should give M second. So we do this one by one. So we'll say actually our original system will be what? I'd like to clear. Sorry, I will read this. So you guys, we can see from this final result. That means, according to the theorem of translation of a force, we translate every force to the point O, right? So actually we get a concurrent force system plus a couple system of transfer M1, M second, and Mn, right? So this is very, very interesting thing, right? So we can see actually after we use this theorem of translation of a force system, of a force, we can translate a general force system in space into a concurrent force system plus a couple system of transfer. No, just like this. Actually, this is the medium state. Our final state is, so you can see. Actually, F1 prime, F second prime, until Fn prime is just a concurrent force system, which it also can be reduced just a final one vector use R prime to replace. So I can write it here. Actually is, I want to write something on the screen, right? So actually R prime, actually it is a reluctant of this concurrent force system. It should equal sigma I equal 1 to n Fi prime. You see? So actually we find that this R prime is very easy. We just do the sum of vectors. Maybe just use the parallel theorem one by one. So we finally can get this R prime, right? Can get this R prime. And the second is the couple system of transfer here. Because actually each moment, maybe I can write it again, we just select F1 as the example. Actually it equal R1 maybe, cross product F1, it equal like this, IGK. This is how we find its magnitude, right? And F1x, F1y, and F1z. This is how we find its final result. And from this, we can use our right-hand rule, 右手定则, right? Right-hand rule, our right-hand rule, maybe actually 右手定则, to find its direction. So you can see this M1, M2, and until Mn, just use the right color. It's more like another kind of vectors and concurrent here. So actually, our final, uh, this one also can use only MO. So this MO more like this, I equal 1 to n each M1. You know, actually uh, the couple also is a vector, because we have two vectors, vector cross product another vector, we will get another vector. So you see, that is how we reduce a false system in space into this one. So, or whatever your original false system is, the final result will just be R prime and MO. You see, if we talk about this false system is equilibrium condition of state, we only need to analysis this R prime and MO is enough. If we just think about this original false system, it's very difficult. It maybe cannot finish the task, but when we use this theorem of translation of a false one by one, we can find actually this R prime plus M0 actually it is the resultant force of the original false system. So when we talk about reluctant force, that means actually this MO plus R prime is effect to the body system will keep the same effect of the original force system. Can you guys understand that? That's the whole principle of us to use the theorem of translation of a force, right? That's how we do this. So let's continue. I hope you guys can understand a little bit, maybe better than that, right? So because the couple in space is a free vector, it can be always translated to the point O. What does this sentence mean? That means if the original force system, we have a lot of force acting at different points, but we also have some couple, maybe prime here, maybe another couple prime here. We can freely move this into O without add anything because it always has the same effect. Because this kind of free vector is actually if a couple is three factors will be 大小 means magnitude and 方向 means direction and 作用面 action plane not action point. Actually, if we can keep these planes are parallel one to each other, so when we move this kind of free vector from maybe this position to point O, will not change any effect of this couple to the body system. So that tells us when we translate a force, we should add a couple. But when we move a couple into point O, we need to do nothing. We can freely move these and this into point O, right? That means the general force system in space, maybe it includes some forces, includes some couples, we can just use this theorem and find its final result just is r prime plus m0, right? So let's continue. Composing f prime 1, f2 prime, m3 prime, and until mn prime, we get the principal vector r prime. In Chinese, we call that 主使. 主 means 主要的 mainly, right? 主使. 使 means vector because we Chinese call that vector means 矢量. It's compared to scalar. Scalar is 标量, it just have magnitude, don't have direction, right? So we get this principal vector, 主使. Actually, this one, we know that actually this one equals sigma fi prime, right? So we can give this arrow to denote that it is a vector. It is a vector, right? And in other words, so I write this. R prime equals sigma Fy because when we do the translational move of all the forces, we do not change its original direction and original magnitude. So actually, when we do this calculation, we do not move this. We can just calculate it R prime at the original position, right? So that means the principal vector r prime passes the point O, and it does not depend on the position of point O. So how should we understand this this hint of this sentence? That means if you like, you can arbitrarily select another point O prime. So maybe O double, maybe O whatever, whichever point, as long as you like. We will find actually it does not depend on the position of the point. Because at different points when we try to find a principal vector, it always equal sigma fi. So in Chinese, we will call that 主使与简化中心没有关系. So we said that the magnitude and direction of principal vector r prime have nothing to do with the point you select. Because we select the point, maybe O prime, maybe O double prime, maybe other point. We try to move all the forces onto this point. But it will have no any effect to the final results of the principal vector r prime. See, this is very important characteristics, right? So let's continue. And composing m1, m2 to mn, we get the principal moment. We call that 主句. So moment in Chinese means 例句, 主句. So actually we can see this MO because maybe some of MI is the when we do the translation of some forces, we add the moment. So the principal moment MO will depend on the position of point O, right? So maybe I can translate this out, explain this. So we only consider one force at F1, maybe here, right? So we just think about that. So maybe the first time we select position at O here. So if we move this F1 to here, we got F1 prime with the same magnitude and same direction. And we should add an M1, right? And this M1 will equal what? Sigma MO, not, I'm sorry, we do not need sigma, MO F, which equal R vector cross product F, right? So this R vector just need to link the action point of F1 and point O we select. So we have this R. Maybe the other time we will select maybe this O prime, and then you can see. This time, if we link O prime, this R prime will a different position vector. It's different from this one. So when we move this F1 from here to here, so this time the couple we added here will have different direction and different magnitude of this. So it's very easy to understand. So that's why the final principal moment MO depend on the position of point O. You guys understand that, right? So we have a force system in space. We can do some reduction precise. Then we will finally have this principal vector R prime and principal moment MO. So whatever your original force system in space is, we will finally find this R prime plus MO. So the difference is maybe R prime have different component along X, Y, and Z axis. And also MO have different component along X and the Y, Z axis, right? So if we try to talk about or try to analysis its state of this force system onto this body, we only need to talk about this R prime and MO, right? So we can find actually this one is very simple compared to this one, right? This is force system in space, and this is resultant force plus couple system in space. Actually, this so-called resultant force plus couple system will have the same effect with the original force system in space, right? That's our principle. That means it is equivalent. In China, we call that what we call equivalent means 等价，等价 or 相当于，效果是一样的 right? Have the same effect 等价的一样的 right? But when we talk the state of this body system, it's very easy for us to only consider R prime and MO. So if we can understand this, we can continue to talk about R prime and MO. So we will just skip this picture. So let's talk about that. So I maybe I should mention this before. The content we are going to talk about may be a little bit difficult to understand, but you guys don't worry about that. I only need you guys have a basic impression. Why? Because actually about 95% our problem we will tackle will be in plane, right? But here we talk about that in space. Actually, in plane is a special case in space. So when we talk about the problem of body system in the plane, it will be very easy to understand because its equation of equilibrium only 3, but in space, its equilibrium condition and equation will be 6. But I try to introduce to you guys in the generalized version. I hope you guys can have a basic impression here, right? So let the center O be the origin of the coordinate system. Coordinate system in Chinese, it is Cartesian system, we call that 直角坐标系, right? It's very often used to denote the 3D system. Sadly, right? 直角坐标, I'm sorry, I write 坐 two times. 直角坐标系, right? System, 直角坐标系, right? 直角坐标系. And then the magnitude of the principal vector is, you see? So this means, I think this means, maybe I can write here, r prime actually is just a vector. It can be read as rx prime along x direction, right? Ry prime along y direction and rz prime along z direction. So from your mathematical course, you have learned this kind of vector. So if we talk vector in space, it will have three components. But when we talk about a vector in plane, it will only have two components. That's the difference, and that's why the plane vector is the special vector in space, because maybe it always have zero component along z axis, right? So all the conclusion, all the principle, it can be applied not only in space, but also in plane. But actually, plane is the special space, right? So the magnitude of the principal force actually is the normal of a vector. It's just in Chinese we call it, it's just a 向量的模, right? 向量的模. Actually, if we call that maybe A, we have a direction OA. So we talk about its magnitude means the absolute value of this OA, right? So just need to use this calculation method. Squared three component squared the sum. The sum of is three component is sum, right? So actually it is the mathematical. So you guys can see it's more like the first homework we talk about today, right? It's more like because it main different to our homework today is just because our problem is in plane. Only to talk about we only talk about the first two without this one, right? So I hope you guys can understand that, right? I hope you guys can understand that. So if we know the three components like r, x prime, ry prime, and rz prime, all these things, the magnitude of the principal force will be very easy to find. We just need a calculator, right? Maybe we just need a software like MATLAB. We can do it easily, right? Then we can find its cosine value. Then we can find its a real angle between this vector with x direction, y direction, and z direction. So do you guys still remember we talked about the projection method? We have direct method. We project a vector onto the axis. We also have indirect method to project a space a force in space. Try to have its fx, fy, and ft. So all these things have very close relationship. Actually, you just need your knowledge of mathematical, right? So let's continue. And according to the relationship between the moment of force about a point and the moment of the force about an axis through the point, do you guys still remember? Actually, I think actually the relationship between the moment of a force, I'm sorry, the moment of the force about a point and the moment of the force about an axis through the point. Actually, we have learned this from the very beginning, from the first or second term of our class. So maybe we can review that again. So I think we have we have a picture like this. So first we have coordinate is x, y, and z, and this point O. So if we have, I'm sorry, if we have force F, maybe we use AB to denote its start point and its ending point of F. Actually, the length AB will denote absolute value of this F, right? So when we talk about the moment of force F about a point O, we can write here MOF, right? It should equal R cross block F, right? So first we should, maybe I will change the color. I will change the color. Sorry. So first we need think the action point of this force. Then we will have vector R. So actually this moment of force F about a point O will be this. So we have this. So actually we can get this once again, R, I, J, K. So we will have three components of R. Use X, Y, and Z. Actually, it is the three component of point A is coordinate value at this system, and we have fx, fy, and fz, and whatever x, y, z, and fx, fy, fz is, we will know actually if we try to find this MOF is component along x-axis. So all we need is to, maybe I have to change another color. Please, you guys pay attention to me. I think this part is very useful. I hope you guys can understand that. So if we try to find this MOF, its X component. So we should first imaginary think we cut the first row, then we cut the first column, then we have a sub expression up here. So maybe I can write here, we have sub like this, RZ, FY, FC. So this 2 times 2, a sub determinant is very easy to calculate. We only need to cross product, and actually this one will be Y times FC plus minus C Fy. No? And once again, if we try to find this MOF is Y component, we need cut the first row again, and this time we will cut the medium column. Then this time we will have this subdetermined X, Fx, and Z, Fz. So here a little bit difficult is that the medium part, that means along y-axis, you guys should remember this time we should do the reverse direction. That means we should this one will be equal ZF and minus XFZ. You guys maybe have to remember that. Actually, it is because the mathematical knowledge, not for our course here. So ZFX minus XFZ. Then the final one, final one we try to find its component along z direction. So we cut this and we cut this. This time we got this sum determine expression x, y, f, x, f, z. It will be normal, so it only need to times cross the and this one will be x. I'm sorry, I will write here at here. Will be x f y minus y fx. This one will be along k direction. So you guys will find actually I spend a lot of time to explain you guys here. So then we'll talk about the relationship between this MOF and this one. We use this. This means all the force uh, uh, is moment to an axis, so the same force, it have moment to point O. It also has three moment to point X, to point Y, and to point Z. Actually, I think I have given you the definition of a force is a moment to an axis. So first, we should find a plane which is perpendicular to this axis. Like this picture, we can find actually plane X or Y. It is the ideal plane which is perpendicular to this axis Z. And if we try to calculate the force F is moment to axis Z, means mzf. So we only need to find MOFXY, right? We should use the projection method to project this F onto the plane. We got it, maybe it's projection force here along normal projection method. This is Fxy. So the definition is the moment of this F to this axis equal the moment of this projection force Fxy to this point O. Actually, it is this. You see? So that's how we give the definition of a moment of a force about an axis. But what's the relationship between this MOF and MZF, MXF, and MYF? So it's very interesting result is actually I spent a lot of time to write here for you guys. So actually, it's very interesting. The final relationship is, please you guys remember that actually this one actually equal MXF. And this one actually equal MYF. And this one is equal MZF. Actually, that's a very important relationship between the moment of the force about a point O and the moment of the force about an axis through the point O, right? So actually, after all this explanation, we can find actually MOF means the moment of point force F to point O actually equal mx. My and mv. You see? So this is very useful conclusion. So maybe in some time, if you are testing to try to find a given force, its moment to an axis. So maybe you can just use the definition of a force is moment about an axis. But if it let us to calculate the three moment of this F2 about three axes, then maybe you can use this relationship. Then you only need to calculate this three times three determined. So just use this. We can find a three moment about three axes. See? So the magnitude of the principal moment actually equals this, right? Equals this. So back to our result here, why we have this speed? Because we just try to talk about, we have finished talking about, we have finished talk about principal vector r prime. So this time we are talking about principal vector, principal moment mo, right? And we find actually mo actually in what? In the moment about the three axes. So sigma fx means all the forces have a moment about the same axis. So we need to do its sum and do its squared sum, then we can get it principal moment mo, right? I think maybe you guys are confused, but I need you guys have a basic impression here, right? Actually, when we do our calculation to tackle some problem or do some homework, it's not that complex like this page. It's not that difficult, right? So try your best to understand that. So maybe I will upload our record today. Maybe you guys can listen again, right? So I will continue. So actually, these two steps, only the mathematical knowledge, right? More like what? More like when we find r prime, its magnitude and its direction. So actually it means r prime and mo also also a vector, right? It is a vector, it has three components. We can use some method to find its component. Then its absolute magnitude and direction is very easy to find using the same calculation method, right? So let's continue. So here we talk about the fixed, the fixed, it's a very common constraint, right? We call that 固定端约束, right? We call that 固定端约束. 固定 means fixed. Fixed. What means fixed? Cannot move. Cannot move, right? So, do you guys still remember actually when we gave actually this is a uh, 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 fixed end in plane, right? Fixed end in plane. Because we talk about we have a conclusion a free body on a plane have three freedoms. That means maybe it can move along x direction, maybe it can move along y direction. It also can rotate around some axis which perpendicular to this plane, right? So if it is fixed at some point, maybe then all the three capable of movement is fixed. So we have the conclusion we can give the reaction force xa, ya, and the constrained moment ma. So each reaction force will prevent one kind of capable of movement from happening, right? That's what we have learned. So after today's analysis, we can, so maybe I can erase all I have right on the screen. So consider the force Fi acting in the same plane. So actually, when this bar is fixed maybe into a wall, actually there are a lot of force acting on the end, on the left end of this bar, right? All these force will constitute a general force system in plane, in the same plane. So actually, a force system in plane is a special case of a force system in space. So we can use the same principle. We can reduce Fi to point A, get the force and the couple. So you guys can find actually this is the so-called principal vector, right? 主使 more like our friend Josephine talk about this, and this MA actually it is 主句, right? More like what we have learned MO, right? So from the capable kind of a number of capable movements, so we can, because we do not know the real direction of RA, so we can decompose RA into two components, because in plane RA this force can be I'm sorry, along this, we can write it xa along x direction and ya along g direction. See? So the direction of RA is uncertain because it is uncertain, but it can be, there should be space. It can be determined by its rectangular components yn and xa. That's why I write this expression, right? It is an expression of a vector in some plane, right? And so YA, XA, and MA are the reaction forces of the fixed support or fixed end. You know, actually, it try to let you guys understand why a fixed support will have three reaction forces. It's from uh, uh, different position. Maybe I think from different perspective to help you get to understand. Actually, before this, we have you guys just from the freedom in on plane only have three capable of movement. So if it is fixed, then these three capable of movement will be prohibited by three reaction forces, right? So actually, we have the same result with different method of explanation, right? So this is from the reduction of force system in plane point of view. So I hope you guys will have a better understand that, right? But we still have about 5 minutes. We'll continue. YA and XA, this A will should be what should be, I think should be uppercase. A. So YA and XA restrict or prohibit, prevent, or whatever, right? Restrict the translation of raised body, and MA will restrict the rotation. See? The same thing. We have talked that a lot of times. So maybe you guys can have a deep understanding of uh, constraint and its reaction force accordingly, right? So let's continue. So actually, this is a picture of this. We will just skip that. Actually, we will move to section 3. We'll do the discussion of the result of the reduction of a force system in space. But I think what we have learned today may be a little bit difficult or complex. Maybe it should give you guys some rest and more time to understand that. So I think maybe we'd better stop here. Okay? I think next time we will start from this section. So today we don't have homework for you guys, but I hope you guys can finish. You should have finished the two problems last time I left to you guys. So I hope you can finish that uh, and send it to me, right? And if you guys have time, you can re-listen the record of today. Later, I will upload the two videos into our WeChat group. Okay,
OK，老师
I
OK，
think
老师
that's all for today. 拜拜。那今天就到这
拜拜。
里，下课吧，好吧，拜拜。
OK OK
我
OK
会
teacher
上传视频的，一会儿。OK，拜拜。
OK bye bye teacher
OK。